So thank you very much, Rachel. I'm wearing the hat for a simple, plain reason. My luggage didn't arrive yesterday, and I didn't have a brush. Was able to shave myself, so excuse my looks. And I'm really grateful and thankful to be here. I know the openEHR community since a while, and I think Thomas and I, we met at the HIMSS conference in 2012. And I was back then at IBM, and we were discussing how to integrate AI into openEHR. I didn't know it had to take so long, but here we are. And here I am presenting. I have an agenda with 5 acts. I'm going to go, I don't know which level you were on knowing AI. I'm definitely not going to explain what AI is. I'm definitely not going to explain what LLMs are, but I try to share some knowledge and experience of what we have been doing at Isaree as well. But I'll start with a personal story. I'm truly fascinated by the internet, by openness. I've set up a foundation to push for open source AI. And on the 28th of April, I was here in Spain. And then suddenly, we didn't have electricity anymore. And I was there with my family and my kids. And after 2 hours, we didn't have mobile connection anymore. And my son started to throw up. And you don't know where to go to when you don't have Google. You don't know how to drive when you cannot use Google Maps or CarPlay from Apple. So I felt myself in a pretty inconvenient situation, but I had a prototype of what we are building, which focuses a lot on decentralization. And I had a Llama model installed on my phone, and it's completely, this is the original speed. So I asked them, where do I find the hospital in La Herradura, which is where we always stay with the family, which is in Andalusia. Sorry for not coming to Catalonia. But I was pretty amazed that in the training data, I could find that information. Then I went to the garage door, and it was electric. I could not open the garage, and I could not drive to the hospital. So I looked if the brand of the garage door was part of the training data set of Llama. And here it was. I could open the electric door, which was blocked. It told me exactly how to do this. And then I went to my car, the rental car, and Apple CarPlay didn't work. And he gave me a description on how to drive. It was not perfect, but it led me to go there where I wanted to go. And I was speechless, although I know that these things were there on my phone. But for me, this felt like having true sovereignty of my data, of my actions, without any surveillance. I live in Berlin. It took us a while to break that wall. But having something intelligence on your phone with not having any connection to a system showed me that probably we will enter a new age of IT as well, where perhaps we process data as close as possible to the place and time of demand. A friend of mine calls this proximity. And we all know this person. So when we looked at the evolution of LLMs, the first paper was published as an open science paper. There's this huge race to build these very close, large systems which need massive infrastructure. They want to kind of monopolize everything. I heard yesterday that now OpenAI is applying for being able to produce sexual explicit content. Probably they need some business cases for the huge data centers. But when these things centralize, I think we have a huge problem, and that's what I've been fighting for the last 6 years. Because if you centralize knowledge into just a handful of companies that are perhaps based in West Coast, California, nothing against California, but as a European, I would like to have sovereignty about my knowledge, then we are in big troubles. Tim Berners-Lee created the internet because of that. Many other people here in the room are following that same philosophy. And probably you know what I'm going to talk about now, but like when Meta, which was the company that I didn't really celebrate, joined the open source large language movement, it took only 5 weeks for someone, and there was Georgy Gerganov, to create a Llama model that could run on consumer-grade hardware. It took only 5 weeks to get there. And this was the moment where, in that open source community of AI, everyone started to work on small models, quantized models. And we have seen quite some revolutions, because what research shows is if you have specialized models and you benchmark them to the bigger models, they can compete completely in accuracy. They're not general purpose. They don't know how to create a Belgium recipe and then do surgery and drive a car. They're very specialized, but they can, on benchmark tests, equal the performance. And perhaps that's why I used that image. They don't consume that much water when they run on your phone. Now, in that evolution, that's 2 years ago, we have seen, next to the quantized models, which is quantization is a method where you kind of reduce the density of your data into bits. Like if you have a 10 megapixel camera, and you would reduce it to a 1 megapixel, and you would take a picture of a Porsche, you would still recognize it's a Porsche on a 1 megapixel camera. That's what quantization do. You have no information loss, and you try to reduce the model as small as possible. But now we see the rise of what we call small or sparse large language models, which are a new method that is really hyped. And NVIDIA published a paper this summer that these models are really the future of agentic AI. Why? I will show that later. But these small models, connected, orchestrated, they will form a sort of what we call swarm intelligence in biology. But these small language models are, and I will demonstrate it later as well, are really very promising. They use not only from the efficiency or electricity, but you need less data. And you see quite a lot of deployments, like the Hugging Face is the GitHub for the AI space in the open source scene. And one of the CEO of Hugging Face 2 days ago posted that in the last 6 months, they saw over 1 million applications of small models on their platform, 1 million. So what we see is here a rise of these small models, of the community delivering those. And last week, I posted this on LinkedIn. There was a tiny recursive model. This is not a language model. It's a very different method. It cannot also not talk. But what was quite interesting on the AGI benchmark, which is a benchmark where we try to perform on artificial general intelligence or the super intelligence, and it was performing with only 7 million parameters better than DeepSeek or Gemini, just based on these tests. 7 million parameter model. Of course, it cannot understand language. This is a recursive model, but you see that the trend in research is really going away from these large models to finding out how can we build smaller models that perhaps run then on my phone. In our white paper, a lot of people downloaded it, which is available for free. We made even a stronger prediction based on our first principle analysis. We made a statement that by 2030, which is 5 years from now, we will be able to run as powerful models as currently openAI does, like state-of-the-art models on your phone. 5 years from now. So if we can run these large models on your phone or on your laptop or on your on-premise, we can decentralize intelligence, and intelligence will come really in abundance without the negative effects of having a monopoly or surveillance technology. We see the same trend on the hardware. Like this week, 2 announcements were made. NVIDIA released DGI Spark, which is a $4,000 machine that does over 1,000 TOPS in that sense. And the MacBook the M5 is being announced yesterday evening. And it will give you computer or like enough power to run 7 billion parameter models in high accuracy, completely decentralized. So we are seeing what I call the personal computing moment. I come from IBM. We did a lot of business still with mainframes, but it's kind of the same history that is repeating ourselves. And what you see here as well, if you look at the green curve, which are the top models, and the red curve is like the small models that are open sourced. I always have this discussion with clients, yeah, but these open source models are not as good. I say, yeah, but like you can do already a lot of value, create a lot of value with these open source models, and you just have to wait 6 months, and then these open models will be able to deliver the similar performance as these large models. So these 6 months are irrelative. If you want to hype your model that you're using is the best model and you start doing just text extractions, you don't know what you actually are doing. Second act, Agentic AI from tool to mentor and building what I call the digital agora from the Greeks. And what is Agentic AI? Like, what is an agent in that sense? An agent is something that has agency, so it's autonomous. It has a specific goal that we train it on, and we need to supervise it, although minimal, because it can perform that task that you give it without any interference from a human, but at the end, you still need a human in the loop to perform. So it has autonomy, it's goal-oriented, it can adopt, and it's proactive. It also can perceive, it can plan, it can act, and I give you practical examples like transcription, the scribes, really hype topic. I think there are 145 startups doing medical transcription these days, but it perceives the clinical conversation, it can think what is being said there, it can diarize, it can understand who is talking, and then it can act on that and summarize then the transcription into a SOAP note or directly into openEHR, as an example. So these agents always are able to perceive a certain setting on data, can act on this after thinking. Technically, these agents as well, they are mostly, not all. I don't go in the agents that don't use large models today, but these agents as well, they can call tools. They have a need for memory, short-term memory, large-term memory. So when they process information, they need to store like intermediate information in what we call the short-term memory, and then you need long-term memory in order to give context. Because without context, the results of these agents are not as performant as we would wish for. The interaction with these agents is through not what we call a chatbot, and I want to make this clear. An AI assistant is not a chatbot. An agent is way more in its use. It can understand way more. Like if you would ask here the dosage of drug X for that adult in a chatbot, it will be a rule-based answer. But an agent really says, like at the end, that it could even ask to write the prescription in the end, and it will look in your patient data, it will look for context, it will look into research information, and it will give you a way more in-depth answer as what normally a chatbot would do. These agents need a prompt. Like if you want to create on the right side a transcription agent, you take an LLM and then you say, you are an agent, and you need to create a SOAP note. So you actually embed like these system prompts or these prompts in your agent. And that's quite a bit of magic. You need to play. If you do too less, if you do too much, it doesn't lead to good results. That's why we call it prompt engineering, because it's an engineering task. You need to start learning how to use language in order to kind of make these behaviors the way you want them to be. And that is challenging because with each model you need different language and you have different outcomes in that sense. But the most important thing, which is now the way we are focusing on, is really the context engineering. Without context, without understanding where in the tasks that I'm just completing, it will be really hard to understand your task. And so this is from our part, but like you need in our space, in the healthcare space, we will need clinical context awareness, you need specific domain knowledge, you need to look into databases, you need to look into research, and then the most important part, you need to integrate it, of course, in the workflow, because without workflow integration, we won't be able to deliver value. And we made a kind of a funny thing here, like from our assistant, we have a lot of clients saying, yeah, but I use an EMR system and I'm missing the APIs. So we kind of, we upload the transcription file so you don't have to wait 20 minutes to listen to a conversation you don't want to listen to. It creates the SOAP note, but then we instruct the agent, use the EMR system, and we used openEHR, and now enter the data into the EMR system. And what you will see the agent doing, it goes to the EMR system, it starts logging into the EMR system, and then it enters the data through the front end. That is not what you want to hear as openEHR people. I know we want to go from the back end, but it kind of solves a lot of problems because we found high-value cases within hospitals where highly paid doctors spend 5 hours a day to extract information for some quality reports they need to accomplish. And they have, for these quality reports, they have 5 hours and they need to do that 100 times a year, and that's just one use case. And if you cannot access your data, it's quite difficult. So these are some of low-hanging fruits. You can use agents and let them control your computer, which already addresses the problem that we need security and everything else. These agentic networks, and I didn't know that when I started working in that, are inspired by biology. And if you look at ant colonies, you will see in these ant colonies worker ants, you see scouting ants who are looking for food. Then you will have guardian ants, and then you have coordination ants, and you have ants that defend the nest. And then you have as well ants that coordinate and orchestrate the work of all the other ants. And we call this swarm intelligence. You see that same thing with birds, with tuna fishes going all together, moving in the same direction. And this is exactly how these agentic systems work. Because we also have an orchestration layer, we have different agents that have specific roles. There is a communication layer, we need to describe the task quite well. And there is, I don't know if these ends have a governance infrastructure and control. They probably don't have any lawyers, so you don't need that. But it's quite similar to what's happened in biology. Then, to let these agents collaborate, you have cooperative agents, competitive agents, consensus-based agents. There are many papers out there. This is very early stage research, but the results are quite promising, and everybody's starting to experiment with these agents. For example, a paper that was published about deep rare agentic systems, and you see on the architecture that, yes, they have the knowledge base, the external data resources. They even go to look into PubMed, into research, and they're starting building agents that can read research. They have other databases they can integrate, and then they orchestrate this. And the results are quite promising because it mostly always overperforms on large language models. So if we use these small models together, we get higher accuracy, and there is one bigger advantage. Each of these agents will probably need to be certified, and you cannot certify a general purpose model. So I think this is the future where we're working on, where agents, similar paper, and that was quite interesting because they created 41 specialist agents, like trained on neurology, trained on cardiology, and they kind of took an interdisciplinary approach of all these agents collaborating together and trying to find a solution on that problem it was presented to. And also here it overperforms on GPT-4 or in this case. And then a paper that comes from Germany, from Jakob Kater, from Dresden, in oncology, similar setting. They also said, like, we have agents in the space of oncology. Sorry for I see now that this is a German-English word. In oncology, and they got 20 complex cases, but they stated as well that this is really good enough to go to a regulatory approval process if you then start doing clinical trials with larger numbers. So what I want to say here with these cases is what the future, I think, is really having a lot of these agents that we will certify, that we allow to orchestrate, bring together, and bring them all together in a single user experience. I mentioned before, there are quite some challenges. Agents have agency. They can memorize data in the model that you don't see, and they could spit it out somewhere else. You need a quite in-depth security layer. You need to make it auditable. You need to be able to do data audit trails. You need to connect it to, these agents need to be connected to an access management system in order to get certain rights. Can I see that patient? Can I go in that depth? So it is not as straightforward as some startups are doing and putting a black box in a hospital. And I know one hospital in Italy who has already 15 of these solutions, and I kind of feel a repetition of the 90s, where everybody was buying best-of-breed solutions, and suddenly they end up with 80, 100 of these black box solutions without having an orchestrated, standardized platform that is based on open standards. Everybody heard about perhaps the AI is going to eat software. When Jensen Huang from NVIDIA told me that, and I'm quite futuristic, but I didn't understand it when he was telling AI is going to eat software. Does anybody understand what he meant by that. If not, I will show this video where somebody is prompting using one of these coding agents, make me a clone of Spotify, but for AI-created songs. And it starts prompting, it starts developing, and you instantly, in 30 minutes, you create a Spotify alternative. So when Jensen said, like, AI is going to eat software, and you see what is happening, the last Claude models, they can run over 30 hours of coding and create 12,000 lines of code and create clones of Slack. I know companies who go to large enterprises and say, like, how much do you pay this big software company in licenses? And we say, like, we will clone it, and then you will save all your license costs. And that's what's happening today. Like, AI is eating software as a service, is eating the software license business, because all these companies are paying a lot of licensing, and you have quite some good use cases here. But now coming to our area, I used to be a product manager from SAP. I'm sorry for that. Like, we promised a lot, but the reality looked then different. So when we promised these electronic medical record systems, we said, like, it's going to decrease cost. It's going to SAP is everything centralized, but the truth is a bit different. The reality is, as we know, all different. So in January, I posted this blog that was then reposted on the openEHR website, that I think the future software stack of EMRs is going to completely change based on what I've been seeing. And I think the next generation of EMRs is really that we're going to move to mentorships, where the user has an assistant, where the assistant is stepping as a first primary agent into networks of agents, where then we tap into data platforms such as openEHR, and where we have loosely decoupled components, all certified based on open standards with an AI-first principle. I think this is going to happen quite fast, to be honest. So that means that we are creating the agentic web, and we will see that there will be an increasing need for these open standardized data platforms. In our white paper, we described that FHIR is nice, but FHIR is an interoperability standard, and it's still a mapping. But if you use 3 different proprietary databases with all the same FHIR interface, and you use 3 times the same agents, you will have 3 different outcomes. You will not be able to automate. So and that's a strong statement, but because you are way more experts as I am, most probably, but what we think is that you cannot automate agentic workflows if you don't agree on a data standard. And that's why I'm standing here as well, because I truly believe this, that openEHR will change this. Now, the interface, everybody has used an SAP system, knows why I said it before. We kind of trained humans to become a machine and then enter the data into the records. And I also think this is going to disappear. I think the interface of the future is conversational, and we will, and this is provocative because I know that from a MDR perspective this is impossible today, we will be able to create ad hoc UIs that are personalized in that conversation. And there are already quite some good examples in digital pathology coming from the US in that. And the reason why I think this is the better solution is that we reduce the cognitive load of these physicians. We all know that these physicians have burnouts, they have 50% of their work is administrative, and I think we need to radically change this. We are lacking resources everywhere. Also in nursing, we have been kind of punishing our employees. And that's why I started out of the spin-off from the foundation, building an open source, what we call operating system, Isaree. Isaree is a Thai name for freedom. So freedom is extremely important. And when I looked at the openEHR advantage, and I said, and I looked at these, and I'm coming myself from the open source AI world, I said, like, this is a perfect fit, because we need replicable AI agents, we need replication of research. It needs to be clinician-led in that sense. We need plurality. We don't need monopolism, we need plurality. And for example, if you have a rare disease agent, how do you gonna, and you package this as a software, how is it a GP is going to use that if it's a software? He's not going to buy a license for a patient case he sees once a year. So you will need marketplaces, and also we have a community. So We're building this assistant with an orchestration layer. I'm not going to go too deep in that. But what we are moving towards to is really what we call away from systems of record to systems of automation. And this is the demo that I presented to Rachel. So we have been working in the last 6 months on building these assistants. And we here it's like, okay, this is a lab report. Like we take a picture of the lab report and we want to integrate it in an openEHR layer. So what we do here is an agent that does OCR scanning. We also did it with CGM data for continuous glucose monitoring. Then it gets being pulled into the context window. Then we call an agent to structure it. And then it's being pushed to an MCP server into the openEHR layer. And it's 100% matching with what is on that paper. So we are able now to take pictures of the lab report, integrate it into openEHR. And we can read, we can take the context, and for some sense of reason, but that's too early, I think openEHR could be acting as a long-term memory in that agentic workflow, because you can store and retrieve all that sort of data. So next year, we're going to release Isaree in a box for research, and we are embracing the openEHR community and are looking for partnerships. And with that, I came to the end of my opening keynote here. And I want to recall a few statements that I think are really important. Like, I think AI in healthcare needs to be on the edge. We should avoid really pushing decentralized systems. Why? We all know why, I think. Small language models are, I think, in the future, not only because they are more efficient and they cost lessly, because they are just performing better when you orchestrate them with other small models in that swarm intelligence structure. So meaning that we have multi-agent systems that are the future of collaboration also between humans, which is very synergetic with openEHR. And then we need network agents that are built on top of open standards. And I repeated here, open standard plus openEHR. This is the reason why we're building Isaree as well and plan this to open source it, because I don't think we will be anyhow successful if we close this and make it a proprietary technology. We orchestrate as well. The orchestration layer is, I think, the most critical part, like the orchestrator for the ends that is orchestrating all these millions of ends. Well, we will see thousands of agents being orchestrated in very complex workflows. I think these papers that addressed or used 54 agents are just the beginning. I think we will go way beyond that. We will see hundreds or thousands of agents being orchestrated to create what we then call swarm intelligence that we can access through the assistant. And with this last statement, I think openEHR definitely offers the best foundation to build this future together. So with that, I thank you for your attention and looking forward.